So now I'm going to talk about spread of your data. So it is exactly what it sounds like. You are looking at how the data is spread across your graph or your number line. So one of the ways that you can look at spread, and the easiest way, is just thinking about range. So range of your data is just literally how many numbers occur in your data, which would be your maximum minus your minimum. And I don't mean as in how many data values, I mean like literally how many numbers across the number line are we looking at for our spread. That doesn't really help us though. It just, I guess, could help us figure out what our tick marks should be on our number line or in our graph. But other than looking at what the data is telling us, range almost does nothing for us. Another one that people could use is the interquartile range. So that would come from when you figure out your 5-number summary from your box and whisker plot. And that is going to be your Q3 minus your Q1. That also is almost just like range, and it literally tells us very little about our data. It's just breaking it up into quarters, and we can look at 50% of the data instead of 100% of the data. But even a better way to look at spread is something called standard deviation. This is what we will be using for the rest of the time in statistics. Standard deviation is super important. Soup's important. Now, people get confused on what standard deviation really is and what it means. So what I want to do now is kind of look at where standard deviation, what it is, where it is, what it actually means. So we previously had talked about, before this, measures of center. So if I am looking at a histogram, a symmetric histogram, because those are always nice and pretty and way easier to work with than the other ones. So if I have this symmetric histogram here, my mean, if you remember, lies in the middle. And so does the median, and so does the mode. But for right now, I just want to talk about mean, and we'll label it X bar. So now, what standard deviation actually is it's the average deviation from the mean. Now, what do we think that deviation means? I mean, this word here, deviation. What does deviation really mean? It means, some people would say, to deviate, and deviate just means to, whoops, hold on. Okay, so I just drew something, and now I'm going to undo it, and then I remembered that you're not actually going to see any of that. So to deviate means just that you are like straying from a course. Right? You're going to change your direction and go maybe a different way. Well, it's the same thing with this deviation. I'm going to change my course, meaning I want to know, on average, how far away are each of my data points when I'm looking at the mean. I want to know, on average, how far do they stray from the mean, to the left or to the right. So that's what standard deviation actually is and what it looks like when we're looking at the graph. So if I look at a histogram in particular, my deviations might be each one of these blue tick marks moving to the right and to the left of where the center or the mean is. So now that we have that, let's look at what it actually looks like with a formula. Yes, there's a formula. Don't worry, you won't have to memorize it because 1, memorization is stupid, and 2, they'll give you a formula sheet on your exam. Yay! So I'm just going to give you one formula because it's the one that we're going to be using the most often. But there are technically 2 formulas. It's okay. They're almost exactly the same. It's not going to be a big deal. The other formula that I'm not going to put down deals with population. We're not really going to talk about population. Why? I'm waiting for you guys to answer, but even though you're not here and I can't hear you, I hope that you're all saying because population is too big and it takes too much time and is almost impossible to find. So we are going to be working with sample. So sample standard deviation has this crazy formula. First, from remembering from the notation video, S represents sample standard deviation. But the formula is the square root of the sum of each x value minus the mean squared divided by n minus 1. Now, I know that seems really crazy, but I'm going to discuss exactly how to use it in another video. And don't worry, once we do it one time the long way, then we're going to learn the short way on our calculators that you will use for the rest of your time in this course, because on the exam, ain't nobody got no time to be doing it longhand. All right, I'll see you all in class.